Okay, welcome to the live stream. We're going to be solving some Advent of Code problems. These are, if you're not familiar, these are sort of leak code, interviewee style coding problems. We're doing 2019 because I'm already caught up on 2020. We're going to be doing these in Swift and Xcode. So if you're looking to be an iOS or Mac developer, this is the stream you want to watch. We've only got about a half hour to go through problems, so we're going to go through as many as we can. So I don't remember 2019. Apparently I did the first 2 days. So we're going to take a look at those problems and solve them all over again since I genuinely don't remember solving them. So let's jump in here. So how Advent of Code works is it gives you sort of a story problem in parts, and you have to come up with an answer. So in this case, I can already see my answer because I've solved it before, but we'll just do it from scratch again. Because turns out in an interview, it doesn't matter if you know the answer if you can't show your work. So let's do this. Most of this usually doesn't matter, but we'll read it anyway. So stranded at the edge of the solar system to accurately calculate the position in space, safely line his warp drive and return to Earth in time to save Christmas. Collect stars by solving puzzles. The elves quickly load you into a spacecraft and prepare to launch. At the first go, no go poll, every elf is go until the fuel counter upper. They haven't determined the amount of fuel required yet. Fuel required to launch a given module is based on its mass. Specifically, to find the fuel required for a module, take its mass, divide by 3. Okay, so here you go. To find the fuel required for a module, take its mass, divide by 3, round down, and subtract 2. So pretty easy. Where is my my puzzle input? Is my puzzle input at the bottom? Okay, here's my puzzle input down here. Okay, so this is all of the masses of the modules. So what they want us to do is, for a mass of 12, divide by 3, round down to get 4, then subtract 2 to get 2, get a mass of 14, divide for a mass of 14, blah, blah, blah. The fuel counter upper needs to know the total fuel requirements. To find it, individually calculate the fuel needed for the mass of the module. So I think what we do is we just add all these up. So what we're going to do, we're going to come over here and we're starting a brand new Mac OS app. Let's do command line tool. I can't remember the details because I don't usually use the Mac template, but this will save us from having to launch a simulator. So makes it pretty easy. Oh, looks like I have an Advent of Code 2019 already. Well, we're gonna create a new one. We're starting from fresh. Okay, so this is the main print hello world. So first things first, when I'm doing Advent of Code, I always do a new file. It's just a Swift file that is the inputs, just because they can be long. And so what I'll do is I'll do let day 1 input equals, and for those of you that don't know, the triple quotes lets you do multi-line input. And then what I'll do is I'll grab this input, paste it in here. So there we go. So now I got the input in here in Xcode ready to be used, which is nice. And then the next thing we're going to do is come over here and we can say the total mass equals 0. We're going to start with 0. And then we're going to split our input up into numbers. So that is day 1 input dot split by, I think that's a new line character. Let's take a look really quick. Well, I guess we'll just debug and we'll see if it actually catches this. So let's do that very first thing, because if our input isn't working, then we're gonna have a really hard time solving this. Sometimes you have to clean up your input to have it make sense in code. Let's see. Okay, there it goes. It's running. Perfect. So we hit this breakpoint here, which we got by just clicking if you're unfamiliar. And numbers, 100 total values. Okay, these are string slices. So let's do PO. Let's just print out numbers first. Okay, that's what we want. Now, the last thing that we want to do for each of these is we're going to map these into integers. So map just takes one thing and turns it into another thing. I think it's this direction. We don't need that. So hopefully, yep, okay, cool. So I did that right. So this takes our input, splits it by the new line, which if you're wondering what split is, so each one of these has a new line in between them. And so it says this is a new string, this is a new string, this is a new string, because there's a new line in between each of them. And then we're going to take each of those individual strings, so each of these, and we're going to say, hey, turn that into an integer. So let's run that one more time and make sure that this works well. Numbers, 100 values. Oh, here's what we can do. So you can see right here, they're optional integers because converting a string to an integer can fail. We want it to crash if it fails because we're just doing a puzzle. We're not worried about robust crash-free code here. If we were worried about robust crash-free code, we could use compact map instead of map. Compact map throws away optional values. But we want to know if something goes wrong. Otherwise, our puzzle input will be off. So that's how you get that. So it turns it all into integers. And then if you're also not aware, $0 in a closure context is the first parameter. So if you had multiple parameters coming in this case, we only have one string, so that's $0. But if you had three, you could get all three of them by using $0, $1, $2. So there we go. So now we got the total mass. And so then we can go through each number. For number in numbers. And then what was the formula for calculating the mass? Divide by 3, round down, and subtract 2. So we do total mass plus equals the number, divide by 3, a int automatically rounds down for us, so that's easy, and subtract 2. If we had to round up, we would use a float and we would use a function called ceil or ceiling to round it up instead of down. So pretty simple there. So divide by 3, round down, subtract 2. Cool. And then at the very end, we want to print out our total mass. So go through each number, divide by 3, subtract 2, add it to the total mass. Okay, let's see what that comes out with. 3399947. 3399947. Okay, that's awesome. Part 2. Fuel itself requires fuel just like a module. Take its mass, divide by 3, round down, subtract 2. However, that fuel also requires fuel, and that fuel requires fuel, and so on. Any mass that should require negative fuel should instead be treated as if it requires 0 fuel. The remaining mass, if any, is instead handled by wishing really hard, which has no mass and is outside the scope of this calculation. Okay, so for each module mass, calculate its fuel and add it to the total. Then treat the fuel amount you just calculated as the input mass and repeat the process, continuing until a fuel requirement is 0 or negative. So, for example, a module of mass 14 requires 2 fuel. This fuel requires no further fuel. Requires 2 fuel. Divide by 3 is, yeah, okay, this is the example from before, right? Yeah. Divide by 3 gets you 4, subtract 2 is 2. So that's 2 fuel. This fuel requires no further fuel. 2 divided by 3 rounded down is 0, which would call for a negative fuel. So the total fuel required is still just 2. Okay. At first imagine, okay, so this is pretty easy. So, so this is the total mass. We want total fuel. And then what we're going to do is we're going to say, I know that total mass is incorrectly named now. I misunderstood what the calculation was supposed to be getting us, but it's okay. So we've got fuel needed. So this is where we're going to start, and then what we're going to do is we're going to basically keep shrinking fuel needed until we get down to 0. So, which we call for 2 sub blah, blah. At first, a module of mass of 1969 requires 654. Then this field requires 216. So we're doing this recursively or in a loop. Either kind of works here. I'm kind of curious, actually. I want to look at my old code and see which way I decided to go on the previous one. So what we're going to do is we're going to say while fuel needed is greater than 0, we're going to continue to apply this calculation to it. So we're going to say total fuel plus equals fuel needed. So that's the first thing, is we get some fuel. If it's greater than 0, add it to the total. And then we're going to say fuel needed, basically this line again, except for fuel needed is fuel needed. And we're going to repeat that until it gets down to 0 or less than 0. And then we're going to print out the total fuel. I think I understand that problem correctly here. Okay, 5097039. 5097039. Cool. That was, it's day 1. They're supposed to be easy. If you didn't understand this, basically you can think of this as an if that just repeats until the if is no longer true. So if fuel needed is greater than 0, which I'm going to assume for most of the inputs it is, then add it to the total fuel, and then update fuel needed again based on fuel needed. Because now instead of calculating the fuel you need for the mass of the module that you're blasting into space, you're now calculating the fuel needed for the fuel. So there you go, loops over it. Just repeats that until fuel needed is less than 0, and then it stops. Okay, now the next thing I like to do is I always like to come in here and do a new file. And this will be day 1. And then I like to take all of this, not the hello world, I don't need the hello world, and do day 1, boom. Okay, so now we have day 1. And numbers, you're correct, was never mutated. Okay, so now my main function can just be day 1 and then day 2 once I make a day 2. This just helps me keep the code clean and organized, because some of these actually get complicated and you're going to need some classes and stuff like that. So let's do day 2. And I might even further split some of the days into part 1 and part 2. Okay, so that's day 1. Let's do day 2. On the way to your gravity assist around the moon, your ship computer beeps angrily about the 1202 program alarm. On the radio, an elf is already explaining how to handle the situation. Don't worry, that's perfectly normal. The ship's computer bursts into flames. You notice the elves. You notify the elves that the computer's magic smoke seems to have escaped. That computer ran Xcode programs like the gravity assist program it was working on. Surely there are enough spare parts up there to build a new Xcode computer. So I think what this is hinting at is that over the course of this entire Advent calendar, that you're going to be building an Xcode computer. So an Xcode program is a list of integers separated by commas, like this. To run one, start by looking at the first integer, called position 0. Here you will find an opcode, either 1, 2, or 99. The opcode indicates what to do. For example, 99 means that the program is finished and should immediately halt. Encountering an unknown opcode means something went wrong. Opcode 1 adds together numbers read from 2 positions and stores the result in a 3rd position. The 3 integers immediately after the opcode tell you these 3 positions. The first 2 indicate the position from which you should read the input values, And the third indicates the position at which the output should be stored. So all of this is just saying to me, these are array operations. Like we have an array of strings and we're reading and writing at specific spots. So, for example, if your int code computer encounters 1, 10, 20, 30, it should read the values at positions 10 and 20. So it hits 1. 1 says you should read 10 and 20. You should read the values at 10 and 20. So you're not reading the numbers 10 and 20. You should look ahead in your array to 10 and 20. And then add those together. And then overwrite the value at position 30, so even farther down the array, with their sum. Opcode 2 works exactly like opcode 1, except it multiplies. Okay, that's pretty easy. Once you're done processing an opcode, move to the next one by stepping forward 4 positions. Okay, pretty easy. So let's get it gives us a lot of stuff. So let's get our puzzle input first. Cool, so this time we're going to split on a comma. So we're going to go let day 2 input equals that. Cool, and we're going to turn these into integers just the same way. So we can actually just copy this. Except for we actually want this to be a var because we're going to be overwriting opcodes here. And the separator is now a comma instead of a new line. Easy enough. So then we're going to go, let's see, for I in, my brain is not working this early in the morning. We're going to do this really quick. Index value. Enumerated, right? Enumerated gives me that's not what I wanted. Where n represents a consecutive integer starting at 0 and x represents an element. Yep, so enumerated, this is a nice little thing if you're not aware. So enumerated basically lets you get the index, so 0, 1, 2, 3, 4, all the way through the array, and the value at that index, which is super nice. Now, in this case, I actually don't know how this is going to play out since, enumerated sequence. I don't think this will actually work because we need to operate directly on numbers. So scratch that. Enumerated is super valuable because you can get the index and the value, but we actually just want the index because when you use enumerated, you can see it returns an enumerated sequence, which I'm pretty sure is a new data structure. The way that this looks right here, this is a new data structure. It's not the original, and we want to be editing the original. So what I think we want to do is I in 0 ... less than numbers .count. Yeah, okay. So this says I want an index I that starts at 0 and goes up to but does not include the count of the numbers. So if you're not aware, because arrays are 0 indexed, you just want it offset by 1. So that's why the ... less than. If you did ... it would actually go 1 too far off the end of the array because the indexes are shifted over 1 because they start at 0 instead of starting at 1. So what we're going to do is we're going to say our operation equals numbers sub I, and then we're going to do a switch on operation. So if it is, well, first what we want is we don't want to ever fall through on our switch. So a switch is going to match some patterns for us. And if it doesn't match the pattern, then it falls through to the default. And again, because we're writing puzzle solving code, we don't ever want it to fall through the default. That means we've done something wrong with our math. Okay, so opcode 1 is multiply, or is add. Opcode 2 is multiply, and then, was that it? Where did it say my opcodes? Okay. 1, 2, or 99. Sorry, 99. 99 is break. So break will just break us completely out of this loop. Okay, so that's pretty easy. So if it's add, what we want is we want the new added total here is going to be, it says 1 more and 2 more than where we're at are the two numbers that we had together. So in the case that they give us here, you hit 1 and this says go to index 9 and add it, go to index 10 and add it. So if we're started at index 0, this is index 1, this is index 2. So the added total is, we're going to do numbers sub I plus 1 and numbers sub I plus 2. Now these are the indexes. This gets us where to look ahead. And then we're going to use those as the index into numbers, which is funny looking. I don't think I've ever seen real code that looks like this, but that's fine. So this will get you, so if we're starting at 0, I is 0, this will get us the number at index 1. And if that number is 90, then we need to go to index 90 in numbers. So if this turns into 90, this will look at index 90 in numbers. Same thing here. If this is I is 0, so this would give us 2. And so if the number at 2 is, let's say, 500, then this whole part turns into 500, and we look ahead to index 500. And then we take those two numbers that we got and we add it. And then I think it said the third number is where we store it. I'm thinking about this right here. Immediately after the opcode tells you these 3 positions. The first 2 indicate the position from which you should read, and the third indicates the position at which it should be stored. Okay, and so then we say numbers sub I plus 3. So this is literally just this same thing right here, except for we're jumping ahead to 3, equals this new added total. Okay, and then this one is the same thing, but just multiplying the two. And then, okay, so this is interesting. So we probably don't even want this for loop, because this will automatically step ahead one at a time. And there is, you can tell it how to stride. So Swift stride example. I don't remember the syntax for stride. Yeah. From and to. Okay. So I think what we want is we want to do stride from 0 to numbers.count by 4. So I think that's what we want. Instead of stepping from 0 to up to numbers.count, we want to do it by 4, right? So let's option click on this to get the documentation. Stride from 0, why would you give a complicated example? By -1, so that counts down. So 0, I think it's is it by 3 is what we actually want? So we want, the first thing is 0. I guess we can find out really quick. We'll just run this. Day 2 input. Okay, numbers, we should have checked that. We didn't, but they're all there. That looks good. Okay, and so I is 0, which is what we want. And then the next time I is 3. 0, 1, 2, 3, which is what we want. Index 2. Okay, I think we're all good there. And then what we should be able to do is at the very end, what did it say? It wants us to, our final solution is to restore the gravity assist programming puzzle and put 2. To do this, before running the program, replace position 1 with the value 12 and replace position 2 with the value 2. What value is left at position 0 after the program halts? Okay, so replace position 1 with 12. Numbers sub 1 equals 12. Easy. Position 2 with 2. Okay. Easy. Equals 2. Okay. What value is left at position 0? Okay, so then at the end here, we're going to print numbers sub 0. Okay. Let's run this. Ooh, we hit an assertion failure. Fun. Also, in our main, we're running day 1, day 2. We don't care about the output for day 1. So we're just going to comment that out. Fatal error. Okay, so we did something wrong, which is, I guess, not that surprising, right? Maybe it is our stride. I think it's supposed to be 4. I could be more thorough about that. Nope, I'm still hitting the assertion failure. Okay, I want to run this and make sure we're getting the right strides here. Okay, so first things first. We should go from 0, 12, 2, 3, and then to 4. So then the next time, I should be 4. Okay, that part is working. And then when did we hit our assertion failure? Is it just like, it's probably climbing out of control. I is 160. Do I misunderstand how this works? Returns a sequence from a starting value to, but not including an in value. Stepping by the specified amount. Okay. To create a sequence that strides upwards or downwards. Is there a different stride that I want? Stride through. So what's happening is that we're hitting I equals 160, which we don't want. Man, and you can see, well, so 160 is 0. So let's see, let's think about this for a second. So if we go through, we've been editing numbers and you can actually see, oh, hold on. I think I misunderstood the problem here. Let's see. 3, they represent the first 4 of the positions of opcode, the position of opcode. To handle this opcode, you first need to get the values at the input. Position 9 contains 30, position 10 contains 40. Add these numbers together, get 70. Then store the value at the output position. Here the output position 3 is at position 3. So it overwrites itself. Afterward, the program looks like this. Just step forward 4 positions to reach the next opcode. This opcode works just like the previous, but it multiplies instead of adding. Okay. So I think that is a concern that we're hitting 160 because, yeah, so here's what I would imagine happens here is you have, let's start over again so you can see this. Well, actually, we can try and let me just try this really quick to save us some time before I take a guess. Yeah, okay, that's 44.8, 448, 4226, 448, 4226. Yeah, so that is basically the problem we were describing before we switched to stride, was we don't want to run over the end. So in this case, though, because stride works a little bit differently, so we're starting at 0, and then we jump to 4, and then we jump to 8, and so you're always adding 4 to it, and eventually the stride ends us at 160, which is a problem because actually where you want to end is right here. That's actually kind of weird. I wonder why it ends at 160. Are there actually, I mean, that actually looks right, 1400. I don't think I'm entirely clear on why that's a problem. But it is. So you look at this, right? So this would be opcode 2, which would be multiply, read from these two locations and write to here. And then stride by 4. I wonder if was it getting 161? See, no, we were hitting this assertion failure, which is actually different. So let's try that again with the bug again in place. It has 161 values. 161, and we're getting to 160. I is, you can see right here, I is 160, which is the wrong index. I'm wondering, I would have expected, so here's what we're going to do. We're going to print I with each loop until we hit the assertion failure, just so we can watch how it's striding. Oh, it's at 156. Opcode 99. It should have quit at 99. I'm wondering if break doesn't get us all the way out of this for loop. I'm guessing that's actually the problem, is we hit the opcode 99 and it should have gotten us completely out of the for loop. Okay. Either way, that's all we have time for this morning. We're gonna pick up this stream later and solve more problems. Hopefully you guys enjoyed this one. We'll catch you later.